Good evening, all. We, on behalf of the SRECAA Alumni Association and the Department of Mechanical Engineering, welcome you for the 95th webinar talk, Opportunities in the EV Space. We welcome speaker of the day, Mr. Shreyas Krishna, faculty members, current students, and all alumni friends. Mr. Shreyas completed his BE Mechanical Engineering in 2010. Then he joined Turbotech Precision Engineering and worked there for 4.5 years. Then he moved on to Quest Global in 2014 and worked for 3 years. For the past 4.5 years, he is with Ether Energy. First, he was a design engineer of battery engineering, then a team lead for battery engineering, then a team lead for battery and motor engineering. Currently, he is a DGM mechanical engineer. Apart from being mechanical, he has completed postgraduate diploma on intellectual property law in the year 2016 to 18. Currently, he is pursuing his MBA from IIM Bangalore. Today, EV is the buzzword in the automobile industry. We are happy to hear from you about the opportunities and trends in the EV field. Over to you, sir.
Thank you, sir. Thank you for that wonderful introduction. And good evening, everyone. Thank you for joining on a Sunday evening. I hope this talk will be useful to you. And I have a bit of a front seat to the emerging EV sector, and I'll briefly walk you through the opportunities that are there for someone graduating during this time. It's an incredibly exciting time to be an engineer in the EV space at the moment, and I hope this will be of use to you. I'll just share screen.
So meanwhile, Shreyas join us. Small update about Shreyas. He's the one who started the SAE club in our college. So that is news for him. So he's such a vibrant student. So during his college days, he was very much focused on starting that SAE college club because there were group placements in it, and he was very eager with Professor Nadal sir, and I was also the faculty in charge at the time. Those are all the good days what we had together in the campus as a student faculty.
Yeah, thank you for that, for reminding me of that, Thomas. I'm actually very proud of having started the SAE chapter. I hope it's active now.
Yes, Shreyas, but the browser, I think you are minimized, so it's gone now.
Yeah, Shreyas, it is very, very active. Student club is very, very active, and they are participating in the national level competitions. They are also winning the events. So they are doing well. So once when you come to college, you can also witness how it has been developed.
Brilliant.
Adding to that, Thomas told that you have started the SAE club. We all recall that. Apart from that, you are very active in all the co-curricular activities, and also you participate in the various paper presentations and other technical events outside the campus. I can also recall that. You were also in research for some time during your third year to final year period. I can recall all these things.
You have amazing memories, sir.
Yes,
some of the things I don't remember.
You always move with the department and asking a lot of doubts with the faculty members. You will come with a new problem and you want to present it to some college events. We can recall that. That is why you are unique in this batch. We could also remember that you were in the gas turbine research establishment for a long time. The drastic shift from that core to EV, that is amazing, and also wondering how it has been happened to you. So we like to hear all these things from you, Shreyas. We can start now.
Definitely. Okay, sorry about the delay in getting WebEX up and running. I mean, every software seems to have its own set of quirks. So, like I said, I'll talk about the opportunities in the EV space. I like to keep my sessions interactive, so I'm deliberately going to keep my slides few, and I actually want everyone in the session to ask a lot of questions about the EV space. Because there tends to be generally a lot of doubts around batteries, motors, motor controllers. How is an EV different? how's the work of an engineer different in the EV space, right? So I don't have a lot of slides, honestly. So I'm really banking on all of you to ask me a ton of questions. Right, like Thomas has said, I graduated in 2010. Why should you listen to me? I think this is the first question. I mean, all of you must be aware that the industry is seeing quite a big transformation, right? The EV market in India is expected to grow really fast for two reasons, right? One is that the total cost of ownership of certain types of EVs is now lower than that of a IC engine equivalent, and two and three wheeler especially are very ripe for this change. So I picked up this little statistic from a report by KPMG. And you can see that the upfront cost differential, which is a difference between a brand new scooter or motorbike vis-a-vis a brand new electric scooter or motorbike, is at the moment 1 to 1.5, right? Which is not so bad. And when you say the total cost of ownership, which is the cost you pay upfront and then the cost of operating it over some period of time, let's assume like 10 years, right? Two-wheelers and three-wheelers are already better. There's no doubt about it, right? So it's with petrol prices where they are and the reliance of oil, as a country for us, it actually makes sense to just shift to EVs. But there are lots of kind of roadblocks along the way, and many companies are trying to overcome that. Right? I'm in one of those companies. Hence, I have a bit of a front seat to how is it that we are overcoming it. And because we're trying to overcome these challenges by trying to build technology in India, there's a ton of opportunities that open up for anybody who's graduating as an engineer at this point in time, right? For you, I mean, for me as an engineer, when I entered the EV space 4.5, 5 years back, the upfront cost differential was huge. It was almost 2.5x. And I mean, I was taking a bet in my career with EVs, but I found the idea of what Ather was doing at that point very exciting. So I made a complete career shift, right? And the bet seems to be paying off at the moment. For you, it's almost obvious. If you're an engineer graduating now, this is a very obvious thing that's happening. One of the key things that you'll realize when I talk about opportunities is that everything is becoming very cross-functional now, right? Earlier, you could be a pure mechanical engineer and you could really find your niche and do only mechanical engineering, right? But today that's changing slowly, especially with electric vehicles, because it's impossible to work on electric vehicle without knowing some of the electronic software sides of it. If you work on a battery, it will come up. If you work on a motor, it will come up. If you work on even I think the chassis is probably the only part where it doesn't come up. Even brakes, even suspension, right? All of these kind of things are also starting to have a very strong electronics software element to it, right? And you might not need to know it in a lot of depth, but appreciating those aspects is also very, very important. And the more cross-functional you can become, the better your chances in this new kind of paradigm, right? So with this kind of premise, I'll go to the next slide. Right? And honestly, this is the bulk of my PPT, right? So what you see here is on the left, I've kind of bunched up all streams very conveniently into 4, right? So whenever if I refer to computer science, I'm also including computer science, IT, data science, all of that into one block. When I say electronics, I include ECE, instrumentation, all into one block, right? Electrical is power, mostly just electrical, right? And mechanical is all the classic streams of mechanical production, machine design, all of that wrapped into one, right? So assume that you have 4 here, and then you have 4 areas, which is generally how companies are roughly structured, right? You will have a research and development kind of vertical. You will have engineering, which is different from research and development. I'll explain that in a bit. Then you'll have manufacturing, and then you'll have quality, right? Or downstream of manufacturing. You have, I should have actually said quality, supply chain, all of that. But you have all of these areas that exist within a company, right? And it's not that engineers only work in R&D. They also work in all of these other streams, right? And finally, there's a list of vehicle subsystems in an electric vehicle, roughly this is how it's structured. You have the battery, which is generally the biggest component by cost. Then you'll have the motor, transmission, controller, which is the powertrain, roughly. Then you have the chassis, suspension, brakes, and bodyworks, which make up kind of the rest of the vehicle. And then you'll have a vehicle control unit and the software associated with it. Right? So we're going to, if you just, I mean, this is a very rough table, but just here, it's 4 into 4 into 4, right? If you are graduating, that's the number of kind of areas that you can pick and choose from and say, okay, I want to work on this as far as the electric vehicle space goes, right? So what I'm going to do is pick mechanical and then talk about the different types of roles that you'll have in, say, R&D, in engineering, in manufacturing, in supply chain quality. And then I'll talk about the different kinds of roles that exist as per vehicle subsystem, right? And I'll do the same for electrical electronics and computer science, right? And then we can basically open this up for questions, right? So let me start with mechanical. That's obviously the one that I'm most familiar with. So the skills that you kind of get when you do mechanical engineering is applicable in probably every industry that involves anything that has to do with hardware, right? As long as you can touch and feel something, a mechanical engineer will be there. And there is a lot of debate, around, why mechanical engineering is not as attractive anymore, this and that. But I'll tell you, even in electric vehicles, right? The most fundamental challenges that prevent, say, battery technology from progressing to the next level, or motor technology from progressing to the next level, are all mechanical, right? So, for example, if you take there is a new battery cell called the 4680 cell that Tesla is developing. The challenges there are not based on chemistry or electrical engineering. It's mechanical. It's how you can manufacture that cell, how you can package that cell, and go read up about it when you have the time. So when it comes to R&D, what you'll realize is the most fundamental challenges with respect to EVs are almost always mechanical, right? And if you're an R&D if you want to get into R&D as a mechanical engineer, now let's talk about batteries, right? As a mechanical engineer in battery, you'll probably be working on batteries that are structural, right? So if you're a battery design engineer in any company, right, chances are that you'll be packaging cells, which is the fundamental building block of a battery pack. We're packaging that inside a battery casing. So the design of the casing, the design of the thermal management, right, the design of even the electrical, the interconnections that happen inside a battery pack, all of them are actually done by mechanical engineers, right? Obviously, you need an appreciation of all the other fields, but fundamentally, it's a mechanical challenge. So, for example, in the Aether 450, which is the product that my team worked on and I worked on, the battery is not just a battery pack; it's also a part of the chassis, right? So that's the kind of work that typically happens in R&D, where you're trying to do new things with the battery pack. You're trying to improve the energy density of a battery pack, right? Now, why have I made a distinction here between engineering and R&D, right? So typically what happens in companies is that companies don't push something that is brand new into the market immediately, right? Some companies do that, they take big risks, but generally what happens is a bunch of engineers work on ideas that are required to come in maybe 5 years later, and they are typically the guys who are working in R&D, right? And the people who are taking a certain technology into the market, they will come in the engineering team, right? So engineering is as important to a company as R&D is, right? In fact, people glorify R&D, but the people in the engineering functions, right, they are the people really taking it to market, and they are ironing out all the small issues that are there with with any of these subsystems, right? So if you are a mechanical engineer who wants to work on design, then you'll have opportunities in R&D teams and you will have opportunities in engineering teams, right? And all of them are equally important as far as getting a product into the market goes, right? So if you're if you're a mechanical engineer with an interest in manufacturing, right? Then, and if you want to work on batteries, then it's a fantastic time, really, because India doesn't have a lot of battery manufacturing capability at the moment, but there are many companies who are getting into it, right? Whether it's Tata, Hyundai, Ola, Ather, we're all trying to manufacture batteries in the country. And typically, battery manufacturing involves a lot of automation. It involves many different aspects of manufacturing to come together, right? So there's two types of manufacturing again. You have the manufacturing of individual components in a battery pack, like for example, the casing or the the cover of the battery pack. Inside the battery pack, there might be plastic parts, right? And then there is the and manufacturing of the whole battery pack itself, the assembly of the battery pack, right? Typically, these are again two separate sets of skill sets. So the manufacturing of the components, a lot of what you learn in your manufacturing technology course, manufacturing technology 1 and 2, that is what is utilized there. So you might be in charge of taking a design, right, and working with a vendor to make a casting or make a forging, right? or make a sheet metal part, right? And there are lots and lots of our seniors and my batchmates who are in this part of the whole value chain. So don't think that R&D and engineering is the end all, right? Manufacturing is equally important. In fact, without manufacturing, there is nothing else, right? You will only have drawings. You cannot bring anything to reality without manufacturing. So if you're in the battery space, typically the kind of components you tend to work on, like it's a casting, sheet metals, extrusion, injection molding, all of these kind of processes are involved in making the components of a battery pack. Now, if you're talking about the assembly part, therein it gets really cross-functional, right? The robotics, automation, IoT, Industry 4.0, all that you hear is all part of battery assembly, right? So there's a nice video, on our website. I'll see if I can share it to Thomas sir, which shows our battery production line to some extent. So there is a robot that picks up the battery cell, drops it into the battery pack, and then there is another machine that's welding the battery pack. There's another machine that's inspecting the battery pack. It's all automated, right? So it's a very exciting kind of stream. It's a combination of mechanical and electrical, electronics, and computer science all coming together, right? So manufacturing, especially automation, is very exciting space, especially when it comes to batteries. And finally, let me talk about quality, and I haven't mentioned supply chain, so I'm going to bunch up those two, even though they're two separate things. What you'll realize as you kind of grow in your career is that in a company, you have to enable materials to come in and then materials to go out, right? The supply chain is the team that enables the materials to come in, the parts to come in, and quality is what enables the materials to go out, saying, okay, this is okay, good to go, right? And if you look at the EV industry today, one of the biggest challenges that is there is the supply chain, right? Because if you take lithium-ion batteries, for example, the demand exceeds the supply of batteries. So as a supply chain, person, you might be an engineer, but a lot of engineers, actually, in fact, supply chain teams are usually full of engineers, right? Which supplier do you go to? How do you evaluate a supplier, right? Today, if there is LG, Panasonic, and Samsung giving cells, how do you decide between LG, Panasonic, and Samsung? Who's the best supplier? And there are many engineering decisions there. Similarly, if you are supply chain manager for a casting, there are many foundries in Coimbatore, there are many foundries across the country. How do you decide who is the most capable, right? So that's what a supply chain professional does. And then finally, on the quality side, all of the things that you studied in your engineering metrology course, all of that comes in handy, right? How do you qualify a part for production readiness, right? How do you ensure that it will reliably work on the field? So how do you reduce the cost of inspection, right? These are the challenges that a quality engineer will be right? And if you're a mechanical person, all of this opens up, right, for you. Whether it's batteries, motors, chassis, a quality engineer is there. Without that, again, you cannot build a product, right? So there is this, especially when I graduated, I had this obsession with only R&D and engineering. That is not, what I'm saying is, that is not the be all and end all, right? There is a lot more beyond that if you're a mechanical engineer. So again, I'll just walk through motor, chassis, and VCU as well. So as far as motors go, again, a motor cannot be brought to life without a mechanical engineer being there, right? Similarly, in an EV, it's not just the motor. You also have something called the motor controller, right? And the motor controller is essentially like a small control unit which is switching the pole so that the motor can rotate, and it does so at a very high frequency. It's a fairly complex piece of equipment, and again, even there, to make sure that control unit is waterproof, that to make sure that it works at high temperatures, right? You need mechanical engineers to make that happen. Transmission, of course, is classic gearboxes, belts, chain. That is full on, mechanical engineering. So there's no doubt about that. When it comes to chassis, suspension, brakes, and bodyworks, all of these are mostly traditional. But if you are working on a chassis, right, you need to have a very, very deep understanding of the manufacturing side of things, right? Which is why anybody who's built a Baja car and a Formula SA car is actually very well prepared to get into a chassis team in any company. If you have actually designed it yourself and built it yourself, you actually pick up most of the skills to do it. Similarly for suspension and brakes. Another thing that's not so appreciated is the bodyworks, right? Ultimately, people buy a vehicle only if it looks good. Otherwise, nobody want it, right? And to make that happen, the manufacturing processes that go into making bodyworks are actually quite complex, right? Vacuum casting, injection molding, a lot of things, and then the painting processes as well. So the bodyworks also requires a very specific set of skills, which if it floats your boat, you should actually explore. Also, a lot of mechanical engineers also tend to be quite creative. So I have seen many people who have gone into industrial design stream, right? So after engineering, they go to a design school like National Institute of Design, or there are design schools in IIT Guwahati, IIT Bombay, where they learn the fundamentals of design and then go into one of the OEMs as an industrial design engineer, right? Less engineering, but at the same time, there's some appreciation of manufacturing processes and so on. And finally, you might think that again, vehicle control unit has nothing to do with mechanical, but even that unit has to be packaged, right? It's similar to the motor controller, where you typically there are injection molded parts, there are castings and there's an assembly process that needs to be defined. So all of these things, again, right down the alley of a mechanical engineer. Now I'm going to bunch up electrical and electronics. When it comes to R&D and engineering, when you talk about these two streams, it's not surprising that a lot of the research and development is also centered in electrical electronics as far as EVs go. It's electric vehicle after all. The main things here are power electronics, right, and control systems, right? So if you are an electrical and electronics engineer, then those are two areas that you ideally want to be super strong in, because whether it's a battery, whether it's a motor controller, whether it's an ABS system, whether it's a vehicle control unit system, you will need those skills of control systems and power electronics, right? So when it comes to power electronics in the battery, you're mostly talking about the battery management system, the design of that. So when typically a battery management system, at least for a two-wheeler, is a 48-volt system with a bunch of MOSFETs and printed circuit board, which is maybe about this big, right? And then there is a software that goes behind the BMS, right? So there's the firmware for the BMS will typically include a balancing algorithm, right? It will include a short circuit detection algorithm and so on, right? So it's almost entirely just power electronics and control systems, right? So you should be incredibly comfortable working with MATLAB, basically testing printed circuit boards, all of that stuff, right? So on the battery side, when it comes to electrical and electronics, it's mostly the battery management system and the design of the cell interconnection and so on. One of the most important pieces in an electric vehicle is the motor controller, and that is a classic power electronics problem. Right? Essentially, you get your motor controller is converting DC into AC. Okay, so if you even though people call it a brushless DC motor that's used in EVs, it's actually not. It is a brushless motor, but it is actually what's called a permanent magnet synchronous motor, right? And a permanent magnet synchronous motor is actually an AC machine, and the motor controller takes, say, 48-volt DC and converts it into AC so that the motor can run. And that is again done by using MOSFETs and some very complex algorithms to figure out the exact timing of when each MOSFET should switch on and off. And this is again completely control systems and power electronics, right? Then you have let me move on to brakes, right? What's also happening with electric vehicles is because these are smart vehicles, there's a lot of sensors on board, right? This is where I think it becomes more relevant for instrumentation engineers, right? Something like an ABS is again a complex instrumentation and control systems problem, right? So something like an ABS is when you look at it, it just looks like a small dabba. But what it's doing is some very complex mathematics, right? It is reading the speed of the wheel. It is reading the speed of the vehicle, calibrating the two, and figuring out how much of the brake should be applied so that your wheels don't skid, which is a very, very complex control systems problem. On the surface, it might look like it's quite simple, but what a lot of, I think, graduating students don't appreciate is that for a vehicle to go on the field and perform reliably, it has to perform in all scenarios, so all corner cases, right? And to test all of that and to have your algorithm and your hardware kind of take care of all corner cases is very long process. It sometimes takes 2 years. So even in brakes and even in suspension, right? We are seeing technologies like active control of your damping coefficient, right? Using magnetic fluids and so on. You're seeing active control of the amount of travel that a suspension has. All of these is, suspension is considered typically very traditional mechanical field, right? But suddenly you have a lot of control systems and electronics coming in. And finally, the vehicle control unit and software. I'm going to spend some time talking about the kind of problem statements that an instrumentation engineer or electronics engineer will face when designing a vehicle control unit. Right. So typically, what a vehicle control unit does is suppose you have a motor that can work in 3 different modes, right? So you have an eco mode, a power mode, sport mode, whatever, right? A vehicle control unit has to be able to read what the user is saying and then convert that into or switch the mode or switch the motor kind of torque and speed map, right? That's what it's doing. It's also got to read the temperature of the motor and say, oh, okay, motor is getting too hot. I have to reduce the power now, right? Or battery is getting too hot. I have to reduce the current to the battery, right? So vehicle control unit is making all of these decisions. It is telling you, okay, how much charge is there in the battery, right? And it, depending on how much charge is there in the battery, it is making a decision of, okay, should I allow you to use power mode now or not, right? All of these kind of things is done by the vehicle control unit. Typically nowadays, because all vehicles are getting what's called CASE, connected autonomous something. I forget the full acronym, but because they're all connected and smart vehicles, right? We are starting to see mini computers being embedded into automobiles, right? So typically this is, it might look like an Android tablet, but what you'd realize in automotive, anything that is not tested for automotive conditions in terms of vibration, shock, waterproofing, it will fail on the field, right? So it's not, you cannot just take an Android tablet and stick it on a two-wheeler or four-wheeler and expect it to work. It doesn't. So uh, the vehicle control unit typically, like I said, has a processor. Some like the Aether has a Snapdragon processor, for instance, and getting that to work under automotive conditions and getting that to work and make decisions around the kind of things that I spoke about is what you will work on if you're a electrical engineer working on a VCU, right? And finally, I'll speak about the software part, right, which is getting very interesting because there is software associated with all of these things, whether it's battery, whether it's motor controller, suspension, brakes, and also there is this whole data element that is coming in. So when it comes to battery, the main software elements are what's the SOC and SOH algorithm. So it's called the state of charge and state of health algorithms. These are essentially algorithms that take data of the voltage and impedance of a cell, right? And then turn that and then use that to estimate, okay, how much charge is there in the battery and what's the health of this battery, right? There is also other software challenges, like you need a firmware for the BMS. So the BMS has to make real-time decisions about whether the battery is operating in the safe zone, whether it's operating in the right voltage limits, in the right current limits, and so on, right? So the firmware is also something that it's usually electronics engineers, but I've seen some computer science engineers get into it as well. Then there is the controller, which is again a giant, like I said, the control systems problem. So here again, the controller firmware is something that's of interest. Similarly, when it comes to suspension and brakes, there's the firmware of the ABS system, and with suspensions also getting smart, those control modules as well. There's software involved, and finally, the vehicle control unit as well. There is obviously there is a front end software. So with vehicles getting smart and connected, you also have a front end user interface, right? So that user interface, which is typically Android or sometimes people use Unix as well. The design of that and the coding of that is a software. It's obviously a software problem statement, and because like again, vehicles being connected, there's a ton of data that's coming out of all of these vehicles, right? So, for example, today I can access data from our fleet of 30,000 scooters on the road. And while maintaining anonymity of the users, we're able to kind of see, okay, what's the kind of riding pattern these 30,000 people are doing, or what's the riding pattern in Coimbatore, right? What does that mean in terms of the reliability estimates of my battery, the reliability estimates of my motor, right? What does this mean in terms of how I should design my next battery pack, right? So there is a lot of data that's emerging from there. Another thing that's coming out is how do you use this data to maybe give customized insurance plans to people, right? If you're a very aggressive rider, and with an EV you can find out like who is riding like an idiot and who is riding like a good how a person should ride, right? And obviously you don't want to give the same insurance rate for somebody who drives very rashly. So think products like these are going to emerge, right? And if you are good at data, and I know that is a very hot field, even mechanical engineers are, I see the data certifications now. Then that is something that will interest you, right? There's a lot of data coming out of vehicles, and people don't necessarily know how to use this data right now, right? Everyone knows this data, but how to turn it into sellable products is still slightly open question mark. So yeah, that's actually, I mean, I'm not sure if I went very in a very ordered way, but you can see that there is no dearth of opportunities. You can do whatever you want in this giant matrix, right? It's you can pick and choose. It's only when you start, looking at very narrow with a narrow set of eyes that then you get stuck, right? If you're a mechanical engineer, don't look at just R&D engineering. Look at manufacturing, supply chain, quality. There's a whole world there. Similarly with electrical, electronics, computer science, don't just look at one aspect of a vehicle. There are opportunities across the board. Even with something like supply chain, if you're a computer science engineer, there is real-time data on say commodity prices of say, copper, lithium, all of this that feeds into the decision making of companies. Of okay, what should we do? What's the next? Should we avoid copper? Should we use some other material, right? So those kind of problem statements. In manufacturing, there's a huge role to play for computer science engineers because there's again ton of data coming from the manufacturing line. So as an example, in the battery production line that ETA has built, we make something like 120 batteries a day, or let me take a convenient number of 100, and we have 168 welds in each of these batteries, right? So it's 168 into 100 welds per day, and we have data of the current voltage force of each of these welds, and we have to make sense of this data and see what's happening with the process, right? Again, it's a beautiful problem statement, and like this, there are 15 different manufacturing stations where you're getting data from, right? How do you use that to ensure that you have a Six Sigma process? How do you ensure better quality, right? So there's an entire world out there, to be explored beyond just R&D engineering. To look at manufacturing, supply chain, quality. They're all equally interesting. I think that's mostly my message, right? Finally, I'll give you some unsolicited advice before I take questions, right? Firstly, build things, right? It's incredibly exciting time to be in the hardware space in India. When I say this, because when I graduated, India's economy was going through a resurgence after the 2009 economic crash, but our placements were limited to, for the most part, right, to software placements and in the services industry. That is changing now because we have this huge startup boom. If you are in Bangalore, I mean, you throw a stone and you land in a startup, right? So, and the exciting thing about this, when you're starting out in your career, is you can take more risks than later in your career. And I would say go to a place which lets you build things from scratch. But to even get into that place, you need to build things in college, which is why something like an SRE club is amazing because it lets you build a vehicle. It lets you build a car, and that's the closest thing that you will get to real industry, right? Similarly, if you are an electrical engineer or a software engineer, just go and participate in as many hackathons, competitions as you can, because it lets you build things, right? And take your projects in college very seriously, because that's where all your learning comes together. Second advice is first principles will hold you in good stead for many, many years, right? So if you've been ignoring thermodynamics, if you've been ignoring design of machine elements, I will assure you that if you actually go to a company that's building things, that will come back to bite you, okay? Because some of these first principles in a hardware company, if an automotive or aerospace company, if you don't make good decisions, it's life or death, right? So suppose you're doing a design of machine elements and you're designing a belt system, right? And you didn't design it properly and it breaks on the field, somebody could lose their life, right? And you really need to know how to apply these first principles so that you design these things correctly. So at no point will your most fundamental courses, that is thermodynamics, strength of materials, if it's electronics, electrical, digital signal processing, all of these things are going to be incredibly valuable in the hardware space, at least, right? So do not ignore it. Third is do original work. Again, I'm coming from my 2010 days. I used to see I used to do this, essentially copy paste assignments and, do it. Like, that's not going to help you, right? Try to be original, try to always do things from scratch. That mentality is what is going to take you really far in your career, right? Fourth is speak to lots of engineers in different companies. Don't be in a bubble where you're just you only know SREC and you're always only talking to your friends. It's incredibly easy to reach out to people on LinkedIn and just network, right? Ask what is, without any expectation, just ask, hey, what's your work like? What do you do? Can you tell me, as a young engineer, what I should be doing to get into this field? Really, people love to help other people. So reach out, speak to lots of engineers. I actually got my first job through LinkedIn in 2010, right? So I was a bit of a trendsetter that way, where Turbotech Precision Engineering was actually one of maybe one or two companies in the whole country that is doing gas turbine design. And I was interested in gas turbines because my final year project was a gas turbine. I actually built a small gas turbine, and the MD of the company was incredibly helpful, and he offered me a job later. So please go and speak to lots of people. And finally, carve your own niche. Don't think that, oh, everyone is getting a job in data science, so I should also become a data science engineer. No, like I told you, there is plethora of opportunities. There is so much to do, and you should actually just try different things and see what you really like, and try to go down that path. Please avoid herd mentality, because then you will realize 2 years into your job that you don't like what you're doing, right? And that's not a great place to be in. So yeah, that's some unsolicited advice for all of you. At this point, I'll stop, and I will open this up for questions. Thank you for having listened to me.
Yeah, thank you, Shreyas. Beautiful session. Students, if you have any questions, please go ahead. Yeah.
Hello, sir.
Hello.
Hello, sir. Actually, என் பேர் ஆதித்யா. நானும் கேஸ் டர்பைன்ஸ்ல தான் ரிசர்ச் பண்ணிட்டு இருக்கேன் சார். மை ஆக்சுவலி மெத்தட். ஸோ ஆக்சுவலி தி ப்ராப்ளம் இஸ் சார், எத்தனையோ கம்பெனிஸ் இருக்கு கேஸ் டர்பைன்ஸ்ல ஒர்க் பண்றது, பட் கண்டுபிடிக்கிறது ரொம்ப கஷ்டமா இருக்கு. அதே நேரம் கண்டுபிடிச்சவங்களோட ஜாபை பார்த்தாலும் லிங்க்டின்ல மேக்ஸிமம் 4 to 10 years கிட்ட எக்ஸ்பீரியன்ஸ் கேட்கறாங்க. அது நீங்க எப்படி எடுத்த உடனே ஃப்ரெஷரா ஜாயின் பண்ணீங்க சார்?
So the secret is starting small. Okay. So I just list out the companies. I'll list out. So right now, if you look in the gas turbine space, the big companies, they all have what we call back-end offices of being modern, right? They offshore a lot of work to offices in India, and typically these offices are in Bangalore. So for instance, Rolls-Royce works with Infosys. They have an office. Similarly, GE has an office in Bangalore, right? Honeywell has an office in Bangalore. Who are the other big guys? Apart from that, you have only government establishments, right? GTRE. And if you look at the manufacturing side of things in gas turbines, then there's actually quite a few companies that do what's called offset manufacturing, right? So there is something called defense offset, which is that the Indian government mandates that if you are giving me a Sukhoi jet or F-16 jet, then so much percentage of the parts should be manufactured in India, right? Otherwise, they won't get the contract. So on the manufacturing side, there are a lot of companies that exist, such as ACUS. Zwork is a company that works in aerospace manufacturing. So you have to kind of, go a little wide. Don't just look at design, also look at manufacturing as well. But if you are only interested in design, then your options are mostly these companies, right? Well, it's the TCS, Infosys, they have back-end offices. Honeywell, GE is actually a great place, but again, GE is kind of picky with their hiring. So typically what you do is, what I did was, I made a giant list, right? I made a list of, I think, 10, 15 companies, and I just found whoever I could on LinkedIn and wrote them wrote them emails saying, I'm interested. This is what I did in my final year project. I want to explore opportunities in your company. And I mean, I make a funny joke here. It's a bit like dating, right? Like if you swipe Tinder 50 times, somebody will say, okay, yes, finally. Similarly, if you send 50 emails, somebody will respond to you and you take it from there. And then you build on that. Once you get into a company, you build, you pick up more and more skills, you build on that and you make your way up. Expecting to be in, in a core group in GE right out of college is difficult, right? Not everyone will get that opportunity, but expecting to get there in 5 years' time is a totally plausible goal. You can absolutely get there. So yeah, I mean that's you start small and work your way up. I hope.
Thank you, Aditya. Thank you, Shreyas. Shreyas, on the chat you have 3 questions from Dhanushekhar, 2018 passed out mechanic. Could you just go into that?
Okay. How do I access the chat now? Oh, there it is. Right. What's your view on cross-badging in EV space? Will it increase the infiltration of EVs in India? Does Ather have any plans to cross-badge it? No, we don't. A very nice veiled question on whether Hero MotoCorp will will cross-badge with Ather. So cross-badging. So typically the industry actually started with cross-badging. Essentially, Chinese imports that have been cross-badged, with an Indian brand, and that's how it's been sold. But the wonderful thing about the EV space and the government as well is that if you just do that today, you will get penalized by the government because the government subsidizes EVs that are designed and built in India, right? So there is an incentive to localize. So almost all the players now have at least localized the manufacturing, if not the design. So I think cross-badging is bad in that sense because people just import and then put their brand and sell it. But the government has made it has at least disincentivized it, right? Second, is Ather involved in manufacturing BLDC motors and controller along with its firmware, or is it partnering with technology partners overseas? Right. So today we do not manufacture our own motors. The reason being, the motor market has a lot of good players, right, in India itself. So you're talking about a Varroc or Lucas TVS or Mahle in India. I think Mahle has a factory in Coimbatore. Our motors come from Coimbatore actually. Similarly, you have several companies, Sona Comstar, Valio. There's tremendous motor capability actually in the country. So we didn't see the need to develop that from ground up. That said, the motor controller, we had a technology partner in Mahle till last year. This year onwards, Ather has switched to its own motor controller, right? And that's gone into production actually now. Similarly, the software as well, motor control software typically doesn't come, is not done in the country. So for example, TVS gets its entire controller software and controllers from Bosch. So that's from Germany, not from India. Bajaj, likewise, all from Bosch, so not from India. Ola as well works with a company called G-Tech, which is Chinese, right? So Ather is actually the first among the OEMs to do it in the two-wheeler space, at least to do it themselves, right? So yeah, it will happen. Like the other people as well will do it in a year's time or 2 years' time. Third question, based on data estimates from your current fleet, what is Ather's MTBF on battery pack? Okay, I cannot give this unfortunately because it's confidential information. How do you optimize the battery life? I want to know what happens in the background. Okay, so optimizing for battery life involves a bunch of different things. Firstly, any battery operates between in a voltage band, right? So typically a lithium-ion cell operates in a voltage band of 2.5 volts to 4.2 volts. Now, if you take a battery cell all the way down to 2.5 volts, or if you take it all the way down to 4.2 volts, the last 5% is where most of the battery degradation happens, right? So you don't do that. Firstly, if you have a battery pack that is say 3 kilowatt hour, right? You always keep the usable size of that battery pack to something like 2.8, because if you use the full 3, you're going to kill that battery pack in 2 or 3 years, right? The second thing is that you need a very, very good BMS, right? That is able to reduce the delta in voltages across different cells, right? So suppose you have 168 cells in the battery pack. Ideally, you want all of those cells to all be at the same voltage range, but that won't happen, right? That's why a BMS does something called balancing, right? Now, if you balance it properly, all of it will be at the same voltage, right? But there will be some millivolt level differences in reality, right? Now, the more accurate your BMS, the less those deltas will be, and the better your battery pack life will be. Now, you have seen of late a lot of safety issues, right? Typically, what will happen and why these safety issues occur is that people will firstly use the entire voltage band, like I said. So they will go all the way to 4.2 volts, and then they will have a bad BMS. Now, what will happen is when you charge your battery, you will go to 4.3 volts on 1 or 2 cells, right? Now, when you overcharge a cell or a battery, you are putting it under unsafe conditions, right? So typically, when you do it over and over again, the battery will at some point catch fire, right? So we avoid all of these things. We are fairly conservative as far as all of these things go. The third thing is when it comes to thermal management and the mechanical design of the battery, right? So typically, you don't want the temperature delta between any two cells in your battery pack to be greater than 5-6 degrees, right? So our thermal design is optimized such that that doesn't happen. The other thing is you don't want your battery pack to get hotter than 55, at most 58 degrees, right? This itself is considered quite high by most people. If you have access to liquid cooling like in a car, then 45 degrees is the best, right? The most challenging thing in battery design is actually the thermals, because in India it gets hot very easily. So you can go to 45, 50 degrees in Vellore or Pune or Delhi very easily. But your battery's maximum temperature, allowable temperature is 55 degrees, right? So you have a 5-degree band to work with. It's incredibly hard, but it's possible, right? So that as well. That's how we manage the battery life. So far, we've replaced very, very few batteries on the field. It's our reliability has been better than we expected. Yeah, so I can't reveal the numbers, unfortunately. That's confidential, but it's fairly good.
Hi, Shreya. This is Suri. How are you?
Hi, Suri. I'm good. Thank you.
Very good. Hey, I joined lately. Sorry about that. I'm not sure you covered, some other perspective of, the scenario, like investment perspective. The EVs is not just booming, but it's going to be exponential growth down the line. So,
Right.
from the investor perspective, do you see any, the space to grow? I see a lot of things from the the charging perspective and solar the perspective, because when we connect the dots so the battery when you go into the EV, there are a lot of room to improvise it, not just the EV space. So there are energy specific scenario as well.
Right.
How do you?
So do you want me to answer from the perspective of an investor or the perspective of somebody seeking investment?
No, from the investment perspective. So I predominantly focusing on the the investment. So I wanted to see how Indian market positioned at this moment to capitalize that.
Right. So again, I would look at the entire value chain, right? So right from the component manufacturers, right, to OEMs, to service providers such as somebody who is making a software to find charging infrastructure. It is just a giant value chain, and there is enough kind of reports and studies out there that list out all the opportunities, right? I can tell you which spaces are getting crowded, right? And which spaces still need kind of improvement. So the spaces that still need more companies to come in set up something are probably the ones you could focus on, because it's incredibly hard to find a good investment in a crowded space, right? So for example, if you're thinking of investing in a two-wheeler OEM at the moment, right? That's a bad idea, because there's consolidation that's going to happen, especially with the bigger players like Bajaj, TVS, Hero, all kind of stepping up their EV plans. The chances of success for a brand new two-wheeler OEM are quite low at this point in time, right? Unless they are focusing on the B2B space, right? Which is not the B2C space, where you're not selling to customers directly, you're selling to businesses, right? Like fleets. So that is a very interesting space, I'd say, for investment. And there hasn't been one player who has kind of stepped up and built a good product for that space. On the auto component side, again, if you find companies that are doing very deep technical work around control systems, right, or something like motor controls, like I was speaking about, right, that makes it a very interesting kind of investment. As far as auto component space goes, right, really looking out for who are the ones making wire harnesses, like who's really good at that, who are the ones who are really good at motors, who are the ones who are getting better at making battery packs, right? So looking out for those, I think that the supply chain for EVs in India is still evolving at the moment. It's not, consolidation hasn't happened there, right? There are still there's still a lot of opportunities there, I'd say. On the charging side, because you mentioned it specifically, again, very, very crowded space. There are just too many startups, too many players. Everyone still hasn't gotten it quite right. But if you are looking for, the right kind of approach, then what I'd say as a battery engineer, the people who are working on providing access to a lot of slow charging points for two-wheelers and three-wheelers and fleets, they are likely to have a healthy business sooner than somebody trying to do a European style fast charging for cars, right? The India is just not there with cars and electric cars at the moment. So there's a couple of companies like Bolt, for instance, and Kazam. These are interesting companies who have figured this out, that to charge an EV, the best way is when you're sleeping, right? When overnight charging is the best. It's the best for the battery. It's the easiest for the consumer. But the problem is there's a lot of apprehension from apartment associations, from even public, even the public. People are just haven't opened up to the idea of having lots of just plug points, right? And the companies that are just figuring out how to put smart plug points, so you can plug it in, scan a QR code, and pay for, say, one or two units, whatever you've used. Just the companies that are able to proliferate a lot of chargers very soon, I think they'll be successful in the near future. I think, yeah, I mean, I hope that answers your question. It's just there are too many opportunities, and I don't know which one to focus on.
Right. Yeah. You touched upon the many things. Thank you, Shreyas. Yeah. I'm predominantly exploring the Indian market. Also, I'm in US, and I'm also looking over here how it is going to shape up, and so I'm looking for the like-minded as well as partners on this space. So anybody in our group wanted to grow along with me on the EV space. I'm very much interested to take it forward on it.
Oh, wonderful. I think I'll connect with you on LinkedIn. Maybe we can continue the conversation.
Sounds good.
Yeah, if you can just drop your email or your LinkedIn link in the chat, I'll make sure I follow up.
Yes, Shreyas. So Suryanarayanan sir is the senior most member of our from our college, and shall I share your contact with Surya sir? Yeah.
Absolutely, it'd be my honor.
Yeah.
Thank you.
I'm one of the the first batch from SREC. Just wanted to introduce myself. So I'm into the the IT space, but so down the line, so I wanted to be the entrepreneur. Build up the kind of small scale to large scale, especially on the EV analytical and the automation space. So we'll look forward and progress.
Absolutely, it'd be my pleasure.
Yeah.
So Shreyas, you have a couple of questions on the chat, like with respect to aluminum air battery and lithium batteries. Yeah, aluminum air.
Right. So good evening, sir. Does Aether work in aluminum air battery? We don't. There is a company called Log9 Materials that work on, I think they work on aluminum air. They're a very good team, again in Bangalore. They're the only startup in India who are actually working on the fundamental cell chemistry, right? It's quite complex work. Can we compare aluminum air with lithium air? I'm actually not very well versed with aluminum air, to be honest. But I'll tell you this, that any a lithium-ion battery, a new chemistry is like a drug. When I say drug, I mean like a new vaccination or something like that. It takes a very long time for it to come to market, right? So even though people, you will see articles every day saying, oh, this researcher has found a brand new chemistry that will solve fast charging, or it will solve it gives 5x the energy density. But the truth is, to take that from lab scale to pilot production to serial production to finally being in a car on the road is anywhere between 5 and 10 years, right? So while there are a lot of potential technologies, they're all at least 5 years away, in my opinion, right? And there are again many articles written around this whole life cycle. It's just like how you have to do patient trials, you would have heard of this when the COVID vaccine was coming out. So it's very similar, because batteries are very finicky devices. Like they fail very easily if you don't do it right.
Thank you, sir.
And
myself,
does
Satish,
it? Sorry. Yeah, go on. Sorry, Satish.
That is, thank you, sir, for your answer. That is, I have posted in the chat. Thank you very much, sir.
Right. You're welcome. I think the last question is, how do one approach to establish a dealership for Aether in a city like Coimbatore? Right. So I will give you the standard answer that my company asked me to give. So there's a way to reach out to Aether through the website. There is a dealership in Coimbatore at the moment. So the way it happens is you have a questionnaire that you have to fill up, and then there is a team that evaluates that, and then reaches out if they see a fit between you and the company, because it's just we have a slightly different approach where what your philosophy is about the customer experience and our philosophy should match, right? Otherwise, it just won't work out. So unfortunately, a lot of people reach out and they don't get responses. We're trying to improve that, but that's the process.
Shreyas, for your information, your senior has taken a dealership of Aether in Coimbatore.
Oh, wonderful.
He belongs to 2006 batch mechanical.
Okay.
He used to contact us for the marketing people.
Right.
He is doing that in Coimbatore.
Oh, what's his name, sir?
Vaishnav of 2006 batch.
Okay, that's wonderful. I actually haven't visited the showroom. I've been wanting to. So, yeah.
It is in Ramnagar, I think.
Yes,
you could remember it.
Yeah.
Okay.
Hindustan Steel's Kikani School opposite, like sir.
Right at the corner.
Correct.
Among.
All right.
Very nice. Yeah, Shreyas, so you had questions on the commercial side, technical side, everything. And as a commoner, for the welfare of commoner, I would like to put one question on safety. So every day when I look into newspaper, I'm able to see one electric vehicle on fire. Is it a man-made thing or really it is happening? That is one question, because when LPG was introduced long back from the petrol conversion, we were able to see odd LPG fires happen. Then all of a sudden everything stopped and everything went well. So upon that, please. Yeah, thank you.
Yeah, so it is unfortunately something that is it's a probabilistic question, right? Like when you ask me that, so let me do the math here, right? Like each Ather scooter has, for example, 168 cells, right? For convenience, let's assume it's 200 cells, right? So typically, any manufacturing process, even if you do a Six Sigma, right, you will get one defect in a million, right? So if you assume that I had 1 million cells, right, then I would have built maybe 5,000 scooters out of that 1 million cells, right? And I can it's possible that I have one defective cell in that 5,000 scooters, right? So you have to design for that defect. Unfortunately, what happens is people do not design for that defect, right? So when I say a defect here, so in a battery, how do you get a fire? An uncontrollable fire is there is a positive and a negative, right? If you short circuit the positive and the negative, you have a scenario where the battery will catch fire, right? Now this short circuit can happen either if you physically do it from the outside, or if from the inside of the battery, right? Accidentally, the positive and negative touch. And that can happen due to various reasons, like mechanical abuse, because you are overcharging the cell and so on. The positive and negative can touch inside and cause a fire. Now, they can also happen because of manufacturing defects, right? Because I mean, try to watch a video of the manufacturing process. It is incredibly complex, right? There is, first they mix the chemicals, then they coat it on a small thin sheet, then they roll that sheet, and then they pressurize it. So many things happen, right? And it's very easy for 1 in a million to have something wrong, right? Some debris gets inside, whatever. So unfortunate reality is that people do not design for that 1 in a million eventuality, right? Unless that happens, I mean, we are going to see more of these incidents. Now, really good companies, something like LG, Panasonic, Samsung, they are able to achieve defect rates of 1 in 10 million. It's incredible what they're achieving, right? But not all the scooter manufacturers or car manufacturers will be able to buy from LG, Panasonic because their supply is limited, right? So then you go to some Chinese player, and then they will have a defect rate of 1 in million, right? So you end up seeing all of these problems. You have to make what's called a fault tolerant design, right? Even in gas turbines, you would have seen tests of a fan blade off test, right? One blade they will blow, and then the engine still has to survive. There has to be a similar fault tolerant approach in EVs. Unless that is done, unfortunately, we will see this kind of issues. And the government is going to step in and make that mandatory, I'm fairly sure. So it will, I mean, the space is new, it is evolving, hence we are seeing all of it.
Yes, I am inviting you for a day visit to our college, Shreyas.
Definitely, sir. I'll come. It's been a long time. Last time I came for recommendations because I thought I'd do a master's, and then I ended up joining Ather.
Okay.
So, yeah, so this time I'll come.
Okay, so definitely I will call you personally for a college. One day visit you can make.
Definitely, sir. Definitely.
Okay, thanks. We have an overall idea about the EVs. Actually, I want to ask the question what Renald asked. Every day we are seeing that there is a firing in the EVs. So it's a question of the safety. So Renald has asked for that. We could understand the reasons behind it. It's a very good overall idea about the EVs. Thanks, Shreyas, for accepting our invitation.
You're welcome, sir. Always happy to talk to anyone from SREC.
Yes, definitely.
So, Mr. Shreyas, I have a couple of questions.
Yes.
The first two questions which I'm going to ask are slightly related. The first thing is, how fast is the charging stations growing? Because ultimately, when I want to travel on a longer distance, the charging station is one thing which is important.
Right.
Second thing, are there private players? It's a part of the same thing. Are there private players who are more interested in setting up charging stations as a business? And is it profitable? And how about the concept of going in interchangeable batteries for the vehicles? See,
Right.
like I drop in my battery at a place and I just snap fit the next one and start my journey.
Right.
So I have heard that concept is available from some companies on a global platform, not in India.
Right.
Is the opportunity open for that?
Right. So let me answer the charging question first. Commercial viability is a problem still, right? Which is one of the reasons you're not seeing like a proliferation yet. It's a chicken and egg problem, right? To make it commercially viable, you need more scooters on the road. To have more scooters on the road, you need more chargers. So it's unfortunately a chicken and problem. But it will happen. The reason being, like I said, like how I started out, the total cost of ownership is better. So the products are better, right? If you ride a good electric vehicle, it's leagues ahead of an IC engine vehicle in terms of your riding experience, right? The only drawback is the range. So and scooters, you will see two-wheelers and scooters, you will see a big shift by 2025. We expect actually, at least 20% of the market to go electric for scooters and three-wheelers by 2025. Then you have a critical mass over which you can build a charging business, right? Especially in urban areas. Today, if you want to build a charging business, the only profitable way you can do it is if you do it for fleets, which is fleets of delivery people or fleets of three-wheelers, right? That's the only way you can build a profitable business in charging today. But I mean, these kind of ventures aren't built on profitability today, right? They're built on some bets in the future, and the bets are looking very obvious at this point in time that by 2025, yes, the market is going to go electric, right? So I mean, it's not a bad time to honestly start a charging business, but like I said, it's a crowded space. Like a lot of people are trying to do it. It's not profitable today, but it will get profitable once there are enough vehicles. Second question you said was around, sorry, I don't recall it.
It was interchangeable batteries.
Swapping. Yeah, right. So the thing is, anything that offers a competitive advantage for an OEM will not get standardized, right? So, for example, if your engine is giving you a competitive advantage, the Activa engine gives it a competitive advantage over a TVS engine or a Suzuki engine, right? They are obviously not going to standardize it. So batteries like that, right? So people will be very, very reluctant to do it. That said, there are two camps in the two-wheeler OEM world. There is a charging camp. So my company is in that camp, right? And then there is a swapping camp, right? So Hero MotoCorp, for instance, has tied up with this Taiwanese company called Gogoro, and Gogoro offers swapping solutions. They have actually successfully built that model. They operated in Taiwan. Taiwan is fully swap, right? Now, Bounce, which is a scooter sharing company, has also started going down the swap route, right? Now, the problem with swap is that it's not a great user experience, right? So if you are an old person, I mean, I hope I'm not making a comment on your age here. I'm just saying if say my grandfather had to use a battery swap solution, each of these batteries about 10 kg, right? So 10 kg you have to lift, put it in, take it out. It doesn't like it works for certain types of people. It doesn't work for everyone. Second problem is it's a very capital intensive endeavor. So now you're not selling the battery, you're selling only the scooter, but somebody has to pay for these batteries, right? And these batteries are going to be in the field. They're going to be used a lot, so they depreciate very fast. So you're sitting on a lot of depreciating assets, essentially, if you're doing a swap business, right? So, the other problem is if you have 1 million scooters on the road, you're going to need more than 1 million batteries for them, because obviously you need some batteries to be available for you to be able to swap it, right? So you have to finance those batteries. And financing batteries is something that's not straightforward because again, they age a certain way, the failure, you have to get a idea of the failure rate and so on, right? So it's a slightly tricky business. And that's why you have not seen many companies step into that yet, but it is happening. And there will be, in some sense, a battle of the charge camp and the swap camp. And over the next 2 or 3 years, we will know who comes out on top. I honestly think charging will come out on top. The reason being, say you have a million scooters on the road and you have 1.5 million batteries you need in, so that they can swap it. You obviously, your financing requirements are going to depend on that 1.5 million batteries, right?
That's right.
Now, if you want to reduce that, you have to charge fast, because somebody, if they put a battery inside the swapping station, right? You want it to charge fast so that's available for the next user. It's a fast charging, in whichever way you look at it, is a requirement. Swapping only is kind of like a, is like a makeshift solution in my opinion. Once you start using an EV, I am an EV user, you will realize that charging overnight, you have 8 hours where your vehicle is sitting there doing nothing. That's the best time to charge it. It's sitting there doing nothing when you're in your office, right? There's enough time to do it. It's just you just need a lot of smart plug points, honestly. So I mean, let's see how it pans out. But yeah.
Right. And one more last thing, like I think a couple of days back, Minister of Road Transport drive to the Parliament on a hydrogen vehicle.
Yeah.
How hydrogen is going to be really a competitor for the EV on the four-wheeler segment, or EV still has an edge over the other?
I think mostly there's a wonderful scale that NASA invented a while back. Not invented, they kind of came up with it. It's called the TRL scale. It's called the Technology Readiness Scale, right? And it's a scale of 1 to 10, and 10 means it's mission ready, it can go into space, and 1 means it's on paper, right? Hydrogen, unfortunately, is somewhere in the middle. It's not yet commercially ready. Hydrogen makes a lot of sense for very big vehicles like trucks and even large SUVs and so on, right? But that technology has to be made commercially viable. It's too expensive at this point in time. It also comes with its own dangers, right? Storing hydrogen is actually quite dangerous. Hydrogen typically causes something called hydrogen embrittlement in all metals. And once hydrogen embrittlement happens, things just break, right? It's a fundamental material science problem that lots of people are trying to solve. But I just feel like it's not gotten to a point where it's commercially viable yet. But it makes total sense for very large vehicles like trucks and even ships and so on, right? And even aircraft, right? I don't think electric aircraft, apart from short haul aircraft, make any sense. Like you have to use hydrogen for like intercontinental flights and so on. So I think it will evolve. It will have its own space. But honestly, I'm not very aware of hydrogen fuel cells and so on. My brain is full of batteries at the moment.
Thank you, sir. Thank you.
Yeah.
Very nice. Very nice. Yeah. So
And I'm sorry, Thomas, sir, one information to you, sir. Your Coimbatore showroom, we did the of course, we are an electrical contracting company. We did the electrical work for your Coimbatore showroom here.
Oh, wow. Okay.
Of course, I know as before, I mean, until Kaustubh sir told, I never knew he was alumni. Of course, I need to speak to him tomorrow.
Right. There's more SREC connect with the Ether showroom than
yes, yes, in a way.
Right.
So the real networking is happening here. Any good news? Shreyas, Vasanth, and Karpsami sir, if there are no other questions from the audience, shall we go for the closing remark?
Yes, sir.
Yeah. Thank you. So that was Shreyas Krishna S of 2010 mechanical passed out. Thank you, Shreyas S. It was a wonderful session. You mesmerized this evening with your talk on opportunities in EV space. SREC Alumni Association is very proud to host you for this webinar talk number 95, opportunities in the EV space. Thank you so much. We really gave you a very short notice regarding this talk, and you really did justice to that. Thank you, audience, for joining in good numbers. Thank you, alumni who has joined across the globe. From USA, we had three alumni joining today. Thank you so much. Thank you, student friends, for joining in good numbers and making this evening more memorable. Thank you, faculty members. Thank you, Karpsami sir, for hosting this. Thank you. Thank you.
Thank you, Thomas sir. Thank you, Karpsami sir, and everyone in SREC. My answer.